Well, good evening, everyone. I'm Peter Dobromylski from Lyncolec, and before I start on the sculptured circuits and SMIs, I'll just give you a quick introduction for myself. Been in the industry for 26 years, which doesn't seem possible in some respects. I was talking to two elderly gentlemen this morning, actually, at the factory. I won't mention any names, Lawson and Graham. You know who you are. They're saying about how long they've been in the industry, and you know, a lot of us are getting on now a little bit, but I just thought originally I had a LinkedIn picture here, but I changed the picture just so that when I first joined PCBs, they still had colour photographs, basically. So in June 2014, I think it was, Spirit brought Technoflex, I'm sure a lot of you know, and it was a big learning curve for me. I hadn't really been involved in flex circuits before that, so only a little bit. So in the last year and a half maybe, I've learned an awful lot. And part of that is the sculptured circuits. It's completely new, the technology, the fact that you could have unsupported fingers that would form the connectors, and a few samples there. The other thing that, although Grant thought he was going to get out of this, I do actually have some samples that Grant will give out. So if you can give a couple out, maybe a couple of bags, 2 or 3 bags per desk. I do need them all back again, otherwise you'll probably get an invoice from Steve. So there's just some sample sculptured circuits there to have a look at while we run through it. So sculptured circuits are incorporated many things from printers to missiles. They're effective form of interconnection. They have thick copper, which gives it mechanical robustness, and the sculptured part is actually where you etch down the... Sorry, you've gone the wrong way. Yeah, it is. It's the bottom one. Yeah. Yeah, so the copper starts out at 250 micron, and you etch down to normally around about 100 microns to make the flexible part still flexible, basically. It's selectively sculptured. I would call it chemical milling, but I mean we still call it etching, but it is very, very accurate etching. And it can be, can be quite problematic, because obviously if you're trying to etch down the 250 micron, it's quite difficult to get the resolution sometimes. So some of the benefits of sculptured circuits, because it's 250 micron at its thickest part, it's very good for carrying power, up to 100 amps, can be carried quite easily. The fingers there that you can see where the sculptured part is. So this bit here is where it's thinned down to 100 microns, and this is the thicker part of the copper here. I often think actually the design guy there was trying to write his name in the connections, but I'm assured that is an actual board with those connections on there. It also has thermal management applications, so it will help with thermal management with this thick copper. Obviously, they're etched, so you can have any shape you like. Because they're etched, you can also etch the features here, so you can etch the holes and any other features, so it eliminates maybe drilling later or any piercing operation. Low tooling costs, it's print and etch, so there are no tooling costs for the sculptured circuits. You can have raised contact points as well, so you can have higher areas here if you want to make a contact with something. They're surface mountable, so not only can they be direct fingers, if you like, they can also be surface mounted. Improved accuracy, reduced weight, increased functionality, and as we've already said, they're excellent flexibility, and they're more flexible than other approaches. So the customized designs, it's ideal for where they're new designs and you're trying to maybe develop a product, because you don't have to start out with very, very high tooling costs. Tooling costs are quite generally low. Sorry, wrong way. All shapes and sizes are possible, and also for the coating, you can do any coating. The only coating that you can't really do is anything with nickel in it. ENIG or just plain nickel, because nickel is quite brittle. So if you're going to form the fingers, it causes problems. So you can add the flat sculptured jumpers. You can see this one here is what we call a formed sculptured circuit, but you get flat sculptured jumpers, and again they're ideal for connecting two rigid boards, multi-layer, single-sided, any boards you want to connect together. You can also connect them together in the panel. So when you're actually assembling a panel of boards, you can use the surface mount to place the connectors on there and connect them all at the same time. It becomes a very cost-effective way of doing it. Generally, the conductors come in standard pitches of 2.54, 0.1 of an inch, or 0.5 mil, 0.022 of an inch. I'm guessing that that is a standard for connector manufacturers, which is why the sculpture jumpers follow that trend as well. Just out of interest, when you're making those, if it's a 0.6 mil pitch, it equates to approximately 12 thou tracking gap. We would recommend, if you need to use probably no larger than 3-inch sculpture jumper. If you get any larger than that, it becomes very difficult to not only keep it flat, but also you can't place anything with a surface mount assembly if it gets bigger than that. So these are some typical dimensions for the sculpture jumpers. You'll be have this afterwards, but so if you can read it if you want to. But you can see here where the copper, you start off with thick 250 micron copper, and then during etching and coating, it reduces it to this part here, which is 100 micron, which effectively becomes this part here. You can also have vertical sculpture jumpers. Again, these parts here are the thick copper. It's not easy to see there, but I think you can just about see where the sculpture part starts. So this part is etched away, and the same there as well. And again, these are literally, as they say, would go onto a PHH board, go through the board, maybe see later, but you can also have some insertion points that will stop the boards going down too far, so you can have accurate height. If you're going to put something else in here, maybe more connectors, the insertion points would stop that going through too far down. Basically, we covered that just then. So we mentioned this before, that all the holes and shapes in the copper geometry are produced during etching. So basically, if you can print it, you can produce it. Some of the unique features we can do. These will be formed. They can be post-formed. So once you've made the sculpture jumper, you can pre-form it and have these pointing different ways. The legs down there, and the same there. We've seen that one already with the different hooks and other features to connect. General tolerances. So this table is based on starting with 250 micron copper. Again, for all of you who like figures, you can look at this afterwards if you need to. They're just general tolerances for manufacture. Terminations. So they're only limited really by your imagination when it comes to the terminations. These are some of the tolerances again. Minimum finger width is 0.3. Obviously, we recommend more if possible, but we can do 0.3. Standard finger length 3.175. And these are some of the fingers. So again, you can have just a straight jumper, or they can be post-formed into different shapes. And actually on this one here, you can see these. I don't know if you can see that very clearly. The little round thing there is the insertion point to stop it. So it will only go into the through hole up as far as there. Same again. So here we have, it's a clearer picture of the insertion point. So these little features here, they actually stop the circuit going in too far and make it stand proud of the board it's going onto. And these ones here show a different feature, which is the reinforced fingers as well. You can have reinforced fingers. It's very common with this type of board, or certainly on one end, to have a ZIF feature. I'm sure a lot of you will be familiar with the ZIF features. Zero insertion force. The other thing you can do on here is have other features such as locking tabs. They can all be designed into these boards as well. So standard plating, we've already discussed some of the plating. We'll just whiz through this. So normally they're tin finish. They can be everything except for so if you have informed fingers, in other words the bent ones that we had before, we'll go back to one of the other ones, that's too far away. But as long as they're not bent, it's okay to have nickel gold or nickel, but if they're formed, we don't recommend you use nickel at all. Some of the other tolerances quite often for the ZIF connectors, because they are quite a high tolerance connector or feature, you do either need hard tooling or you would need to laser the profile. I'm sure a lot of you will be familiar with silver screening, and again we can use silver screening on the sculptured circuits with possibility to bleed the silver through to make it a whole 360-degree screen effectively. But the only thing we would recommend is where it's been flexed, you would probably need the hatching finish on there to still give it its flexibility. So that leads us on to SMIs. Again, this is completely new to me until a year or so ago. So SMI, surface mount interconnects. It's a form of sculptured jumper, but it's become more of a component now. So they're very small, designed to go on. We've got a sample here, designed effectively to be reeled, tape and reeled, so that they can be used on a surface mount assembly machine. You can have a look at that later if you like. It's the same profile. So you start off with the same thickness of copper, and it's profiled down. So low-cost component is what it turns into. Obviously, when you're making a small board like that, you get an awful lot on a manufacturing panel. And then they are designed to be pick and placed with the standard 13-inch reel. Conventional solder reflow, physically robust, obviously, flexible and reliable, very lightweight. The small ones I think we do, the smallest one we do is probably a 5 finger, so it's very, very small way of connecting two boards together. And the low profile, where they're formed, it only stands about 1 millimetre high. Again, excellent current capability because of the thickness of the copper when you need it. And excellent just as a once only bend and install type operation. It's not the kind of thing where you would keep flexing it. And the standard finish tin is obviously ROSH compliant as well. We do have standard codes for customers. These are kind of heavily invested in some of the tooling for these. So we do have a standard range that we keep. The tooling, you can have other ones, custom versions, but then obviously you need to invest in the tooling, or there will be quite a high tooling cost associated with that normally. So the benefits again, low space. It's much more costly to develop a flex rigid multi-layer, whereas you could get, we'll see a picture in a minute, where you can basically have a panel of rigid boards with these small interconnects in between. Also, it does away with the need for stack connectors or connectors with wiring harnesses. So this here is effectively, why I put a washing machine there? That was a good question. It's really to illustrate the fact that by using the reel and surface mount assembly, they can be used in pretty much anything. Cost is not a deciding factor with it. So this is an example where you see the small sculpture jumpers, small SMIs. This is the mother panel, and then during the assembly of the components, you would also put these on there with the pick and place machine at the same time. So when you break the boards out of the mother panel, you effectively have a flex rigid board. So some of the applications. Said before, if they're too large, not only do they have a tendency not to be quite so flat, but they also don't lend themselves to tape and reel. So you can't pick and place them with a machine. So once the PCBs are manufactured, they then have to be put onto the tape and reel. And so obviously this is an automated system we have, the machines to actually put them into the reels, tape them and seal them. Now just a few applications. I mean, obviously they can be used in anything that needs an interconnection basically, but we do have currently have uses in aerospace, hybrid cars, used a lot in hybrid cars, defibrillator, it's like a household electricity unit, medical, lots of medical applications, customers at the moment, water meters, and one of the things that one of the samples you have, how do I do this one, Bill? Excuse me a second. I can see it. Can't work it. Hey. Thank you. This is also another application. One of the samples you have actually is used in this missile. Yeah. So, high velocity missile. Just wait for this to finish a second. It's much better with sound, I have to say. The geeks among you'll realise that actually isn't hitting the tank. And I am a bit of a geek when it comes to things like that. And apparently the missile has 3 fuses. One of them is impact, one of them is a magnetic fuse, so it knows when it's in the right area, and the other one was just above me. I didn't even realise what it was. It has 3 fuses. I think a lot of us here are on the coal face a lot of the time, and sometimes it's difficult to actually put your head up and see what's going on and see how important things are that we're doing. We all have problems, different problems on different days, but it's important that things work, and we take it for granted a lot these days with everything we use. Everything's electronic, that it'll work. With a missile, maybe it's a slightly different problem if it doesn't work properly, because in case it acquires the wrong target. But even if it's a printer, whatever it is, we still expect it to work. You know, we do some amazing things at Lyncolec for some amazing projects, and so you do take it for granted sometimes. It's good to sit down and talk about what you're actually doing sometimes. Export applications, we export these little things all over the world, would you believe? So there's some of the countries. You can test me, I do know what all the countries are. Even though some of them are very small. But they're current customers around the world for these small sculpture circuits. And I think that's it, pretty much.